Unix. Today we are going to learn about the Unix. Unix is a operating system that is widely used nowadays for most of the servers and business applications to process the day-to-day life computing, or we can say business requirements. I'm going to open this presentation. Let's start with the first slide. I'm going to just read that and explain whenever required. Unix history. Unix officially trademarked as Unix, sometimes also written as Unix, the U capital and remaining letters NIX lower, Unix in small caps. Let me take one pointer. This one is a multitasking. Unix is a multitasking. So multi-user computer operating system, originally developed in 1969 by a group of AT&T employees at Bell Labs, including Ken Thompson, Dennis Ritchie, Brian Kenningham, Douglas McLaurin, Michael Lesk, and Joe Osana. The Unix operating system was first developed in assembly language, but by 1973 it had been almost entirely recorded in C language, greatly facilitating its further development and porting to other hardware. Today's Unix system evaluation is split into various branches, developed over time by AT&T as well as various commercial vendors and universities. Universities such as University of California, that is Berkeley's BSD. So let's go step by step to explain this. Unix is a multitasking and multi-user computer operating system. Yeah, this multitasking and multi-user that we will explain. I will explain in the remaining slides. But it was developed in 1969 by a group of AT&T employees. So AT&T is the main company which originally developed Unix operating system, and there are some other universities such as this California's Berkeley University. They developed that. So in the beginning it was in assembly language. Where is that assembly language? Yeah, this one. Initially it was in assembly language. That assembly language, you know that 8085, 8086, those microprocessors, they have assembly language. They run on assembly language. This operating system was initially developed in assembly language. Then later on, after years of development, that was converted or developed in C language. Why after developing in C language? That was the main advantage was to port this operating system to other hardware. So other hardware, different kind of hardwares are available are were available at that time. So this Unix operating system uh, was developed in C language in order to port means like it should run on different kind of hardware. This okay, now let's go to another slide. Let me make one quicker change. Increasing volume of that. Slideshow. Okay. So that we know when we are jumping to next slide, we know when we are jumping actually. So overview: the Unix operating systems are widely used in servers, workstations, and mobile devices. So mobile devices, servers means like big servers, like mainframe servers or mid-range servers, or Sun Microsystems large E25K and E10K, and the IBM's mainframe servers, or HP Superdome. Those are all called big servers. Workstation means like a small servers, like uh, uh, the computer which have less power. Those are called workstations, or even sometimes PCs are also called workstation, and mobile devices. Uh, so let's mobile devices mean like smartphones, like Blackberries and iPhones, and those are Galaxies and all those Nokia. I mean, those are mobile devices. The Unix environment and the client-server program model were essential elements in the development of the Internet and the reshaping of computing as centered in networks rather than in individual computers. This client and server concept is basically there is a one server and so many small computers or small PCs. So on server there's a big program runs, and this client can send the queries to the server, and server processes those queries or answers those queries or questions back to the small small PCs or small workstation. Those are client. That means the one program runs at center at server place, and there are hundreds of people who are sitting at different locations with different PCs or small client workstations. Then the server can interact or process their request. So that kind of model is called client-server program model, and that was required in order to develop the Internet and the reshaping of computing as centered in networks rather than in individual computers. So earlier we used to have like a single machine, and there were like so many programs we used to run on the same machine, but that machine or PC or laptop or any small workstation, that was not powerful in order to process the data. So you had to the you can say engineers and researchers, they had to distribute their power like among the so many workstations and servers. So that's why this network came into picture. Yeah, network was important. Like this I have one machine, I have another machine, and so one machine is talking to another machine and getting the uh, results of your programs or applications or whatever process. That at that time the network was important, and because of that, this internet also started, and the computing was computing whatever computing you are doing, like running the programs, that also enhanced, its power enhanced, like okay. So that is the this one. So originally Unix was meant to be a programmer's workbench more than to be used to run application software. The system grew larger as the operating system started spreading in academic circle, as users added their own tools to the system and shared them with colleagues. So initially it was like programmers language, but so many people, so many programmers started working on that, and it expanded. And the next one, what happened is both Unix and the C language were developed by AT&T and distributed to government and academic institutions. In 1960s, the Massachusetts Institute of Technology, that is MIT, okay, AT&T, Bell Labs, this AT&T is another, Bell Labs is another company, Bell Labs, and General Electric developed an experimental operating system called Multics, Multcs. Multics means you can see from this something, multi means more task, something what is called computing system, something like that, Multics, for their mainframe, the GE's mainframe. Multics introduced many innovations but had many problems. So you know that now the Unix was already developed, but before that also these three companies, MIT, Bell Labs, and GE, they developed one project, and that project's name or operating system name was Multics, but it had some problems. Let's see what happens next. Bell Labs are frustrated by the size and complexity of the Multics, but not the aims, slowly pulled out of the project. Project team of Bell Labs researchers led by Thompson and Ritchie, including Rudd Canady, developed a hierarchical file system. This hierarchical file system is an important word. The concepts of computer processes and device files, a command line interpreter, and some small utility programs. So these people, these guys, the team of researchers at Bell Lab, they started working on that, and they created they have put in or added some features. Those are hierarchical file system and computer processes, device files, and command line interpreter, and some utility programs. So that means it was already there, but to increase the power of that, they put in these additional features. So what happened in 1970s, Peter Newman coined the project name Unix. That is Unix, how this uniplexed information and computing service. Okay, as a pun on Multics. Pun means like giving some different name to that, Multics. Unix, you can see this. this multi-X and Unix. Unix could eventually support multiple simultaneous users, and it was renamed Unix. In 1972, Unix was rewritten in the C programming language. Okay, so initially it was multi-X, and then later on it was Unix. In 1991, Linus, Torvalds began. This is the name of the one person. Began work on Linux, and the Unix clone that initially ran on IBM PC compatible computers. So what he has done, he took that Unix code and his name, Unix, okay, Linux, right, and he has given the name Linux, and the same code and to run on IBM PC compatible computers. Okay, so next let's go. So here, even though it's not completely visible, but this is the complete history of the Unix. Initially it was Unix, and these dates are given in 1909 and all those. So Unix initially, we just now learned Unix and UNICS, and from there they have started so many versions. Unix 1 to 4, and then BSD, that Berkeley software distribution, and there are so many same time the three colors means open source. This green means open source. Open source means that code is available for developers or anyone who would like to do modification. So these are the, so you can see like Linux and this Matrix and all those BSD, and out of these four you can see that these are like the 1970s, 87 and 1994, 93, and there are the versions. Like for example, we are going to give more stress on the Linux, and you can see like 1992 here, that was like version 1.2 or something. Then it came over here, it's 1997, and Linux 2 to 2.6, and it's like Linux 3 or something, 3.0, 2010 and 11. So similarly, this is another one, and the Sun OS, you can see Sun OS, that is 1 to this, and the Sun OS 3.0 and Sun OS 4. That Sun OS 4 you can see like 1987 to this one 93, 92. Okay. Then the Sun OS, Sun Microsystem renamed this Sun OS, and then they have given the Solaris. So Solaris started from like 91 through what is this 2005, and they have like more like Solaris names, and that now it is, I think, Oracle's Solaris now. It was Sun Microsystem, now it's Oracle's. This is also Open Solaris also. So if you can see that, and this another, this Linux Solaris, right? Then this is Sun OS we already learned. There is one called AIX. This is IBM's one. You can see the IBM's AIX is starting from this something 84, AIX 1.0. So you can see all the AIX all the way up to AIX 7.1 in 2011 and 12. So AIX. There is one more HP Unix, that is HP Hewlett Packard's Unix, and that is, you can see, like 1985 through all the way 97, and they have again an HP Unix 11.0, and so those are up to 2000. Yeah. So you can see like how many different flavors, Linux, and then Sun Solaris or Sun OS. Then you can see like AIX, that is IBM's, and HP Unix, and also Open Server. Then SCO Unix also, you can see this, that was Microsoft's one, SCO Unix. These are so many operating systems you can see. Let's go to another one now. So just now we discussed that like so many flavors. So here, this introduction we are starting now. Let me read this Unix introduction. This is topic 2. Unix began to grow more and more in use with the massive development and expansion of the internet. Linux, an easier version of Unix operating system, and Unix are both found almost everywhere. So this actually Linux is also like another flavor of Unix code. Yeah. Okay. So to ignore them is simply impossible. What are the Unix versions? We cannot say versions, but we can say Unix flavors. There are like one code, and it has got different flavors. So Sun Solaris is one flavor, that is called Unix. These also, everything is called Unix, but that is developed and manufactured by different vendors. So for example, the Sun Solaris, the Sun Microsystems Solaris. Okay, so Solaris is the operating system. Another one is AIX, that is developed by IBM. BSD, that is also is a Berkeley University's Unix. It's Linux. Different vendors are working and manufacturing and developing Linux, and one of them is Red Hat. That is nowadays I think most popular. Another one is SUSE Linux. That Linux is developed by the Novell. We can say developed, or we can say it was already there, but they have put in different features and tools and utilities in the original code, and have given different names like Solaris, AIX, and Linux, and SCO, and all this. Okay. So now you have to keep in mind these are 4 flavors of the Unix, 4 or 5 or 6. There are more, like HP Unix, and now it is going to be discontinued. HP UX is going to be discontinued because nowadays they are focusing more on Linux, I think. Okay. Unix code type. Unix code of above versions is written either in BSD or AT&T System V. Okay, that AT&T System V. This is the System V is another is the system that is that complete Unix code is System V. Okay, now let's. Okay. Although these versions of Unix operating system have differences, they all share the same thing. What is same thing in there? Unix kernel. Unix kernel is basically the, we can say, heart of that operating system. That means even though there are different versions or flavors of the Unix, they have the same brain or same kernel. And the different vendors and manufacturers, they have just added additional utilities into original code. Original code, that is Unix kernel, and some additional libraries and software packages. So Unix kernel can be openly worked on and developed by anyone with the knowledge to do so. So this kernel can be developed or modified if you are the programmer and you have the patents and rights and knowledge to do that modification or enhancements. Features. What are the features? Features means what is available in that operating system. So multitasking. So multi means more, right? More than one, and task means like our work. So multitasking means more task, more work at the same time. So Unix is a very powerful multitasking operating system. Multitasking means doing multiple tasks at once. So this Unix operating system can do multiple tasks at one time. Multiple tasks means like so many tasks. Like it can do that printing, it can generate your report. At the same time, you can do whatever you have from the web. You are sending the queries to your database server inside the database, and this operating system just handles so many tasks at one time. Like if there are like hundreds of thousands of users are sending their questions and their programs, actually the hundreds of users programs are sending questions or queries. This operating system, Unix operating system, can handle at that complete load at the same time, and that is we'll discuss that later on, how it can handle. Basically, let me check whether if this is the task and this is for example CPU, right? Processor. That processor and the Unix operating system, they work together to finish the part of the task. This is for example, this is your complete task. That may be like any your printing job or something. There are so many tasks. So that task or so many tasks can be divided into parts. Then it finishes this part, then writes in the memory something that this must finish, like 50% finished or something. Then it leaves that there. Then it jumps to the next task and checks how much finished. Okay, and it takes from there and starts the remaining part, the pending part. The pending part may be anything, and then it goes to next one. So that means if there are like so many tasks, it divides the task in parts and finish one by one. It's not one by one. It's like a finishes very quickly small part and then go to another one, and it is so fast that the user, like so many users, they cannot recognize that your work was kept on hold for a moment because the CPU and operating system was working on the another task. You cannot recognize that. The way you like for example, I can give one example. In the movie, when you watch the movie or moving picture, the audiences have been provided like 30 or more than 15 pictures in 1 second. If 15 pictures are shown to the audiences, then your eyes cannot recognize how fast how fast was the you know the this I can say. So the moving picture is so fast that you cannot recognize human brain or eyes cannot recognize that so fast, and it looks like the picture is moving. Your picture is not moving actually. The number of pictures are shown in 1 second are too much, and for the human being it looks like the picture is moving. Okay, the same way it happens in the operating systems of processing. The the CPU and operating system processes the task so fast that the users and or any other program they cannot recognize that, they don't feel that the job was on hold for a moment or for microseconds. Okay, and that's the way that the tasking was or so many tasks are done or handled by the operating system. Okay, so multitasking. So multi-user from this name uh, you can easily recognize that the many users simultaneously can use the same machine. So meaning of that you can easily recognize. Okay, so these are the features like so many tasks are being done by the operating system, and so many people can work on the one machine or one operating system. Okay, then open source. Users are free to look at and modify its code. Okay, that's called open source. This is the main code. You can modify that main code, but that is not easily available for anything. Like if I went there and I asked, okay, give me your main Unix code and I want to modify it, I will not get that, because they check how much whether you are eligible and you have that qualification and expertise to modify that code, and what is the purpose. That those factors are important. Okay, and then let's go to another one. Log into the Unix. That is the third topic. To log in into Unix system, you need to log in with credentials. Credentials are tied to the accounts on the system. Credentials means what are your rights you have got. What are the privileges, and you have to use the privileges to log into the, like your username and the password. You have to provide that, and after providing that, you may be like a simple user or you may be like a super user. So depending on what are your rights or what are your credentials, you will get a prompt. So accounts are created by the system administrator. The most of the people who are watching this today are most likely will be the system administrators for the Unix operating system. System administrators, and in short they also call SA, Unix SA. Okay. There are different types of accounts. Some accounts have more privileges and some have less privileges. Root is the administrator's user account. So this root name is very important. Root means the name. This is the name of the user, and who is the super user of that operating system, and it has the most privileges available to the system. Most privileges means root can do anything. Root can install the operating system. Root can destroy the operating system. Root can add him. Other users, and create a file system and create so many things and kill the processes, and a lot of things root can do. Root can do everything. Okay, so root can do means